Alrighty, folks. I've had a couple of you ask about this question. So first of all, this requires the technique of logarithmic differentiation. I'm going to go a little bit quickly through this example. I recently posted another video called section 3.9.56 or number 56, something like that. So if you'd like an example where I go a little more slowly through the concept, please take a look at that. So I'm going to go ahead and set this function equal to y, and then say that this is y equals 1 plus 10 over x all to the x power. So remember, I know how to take the derivative of an exponential function, and I know how to take the derivative of a power function using either of those rules. But in this case, I have both a variable base and a variable power. So neither of those rules will apply. So that means we're going to use the technique of logarithmic differentiation. So what do? Well, we first take the natural log of both sides. So I've taken the natural log of both sides. Why did I do that? Well, this enables me to utilize the properties of logarithms that says I can pull powers outside of logarithms as factors. So essentially what I'm doing is, this was difficult to evaluate, so I'm separating the exponent from the base. So that gives me the natural log of y is equal to x times the natural log of 1 plus 10 over x. Now we're ready to differentiate both sides. Okay, taking d dx of both sides. On the right-hand side, I get 1 over y prime. If you want a better explanation of that, do take a look at the video that I referenced here. And on the right-hand side now, I've got a product rule. So here it is. Here we go. We've got the first times the derivative of the second. Then, and I'm not done taking the derivative of the second, I've got a chain rule here, so I've got to multiply that, and I'm just going to go ahead and do that. That will give me negative 10 over x squared when I take the derivative of this denominator right here, this expression that was inside the logarithm. If you want an explanation of that, I'll go ahead and give one here when I've finished working through the problem. So again, we're looking at a product rule problem. Here's my first, and then this was my second. So right here I've got the first. All of this right now is the derivative of the second, doing this product rule. Then I can go ahead and add to that the second, which is the natural log of the absolute value, or excuse me, the natural log of 1 plus 10 over x, and then times the derivative of the first term, which is 1. So let's just get caught up here. This was our second term, and then times the derivative of the first. Oops, that didn't turn. Times the derivative of the first. Okay. So let's see what we can do to clean this up some. So before I worry about this y over here, let's see here. This x, when I multiply this to the negative 10 over x squared term, it will cancel out, and it will cancel out one of these factors of x. So let me go slowly through that. I need another color. Let's do this. So this x will cancel with one of those factors right there. So in the numerator, I'll have minus 10 over, and then I'm going to go ahead and distribute this x to both terms in the denominator, which will give me an x plus 10. So again, what I did here was I distributed this x to both terms in the denominator. That's how I ended up with x plus 10 there. Okay. So that's how the first factor simplifies, and that's actually pretty nice. And then the second one, there's nothing really to simplify there except for that 1, so you get 1 plus 10 over x. Okay. So now at this point it's similar to all the other logarithmic differentiation problems. I'm going to go ahead and take the this y right here, multiply it over to the other side, and that gives us negative 10 over x plus 10 plus the natural log of 1 plus 10 over x. Okay. And then we can go ahead and back substitute what y was. Well, what was y? Y was this expression right here, 1 plus 10 over x, all to the x power. So all I did here, so in place of this y right here, I wrote what we set y equal to. And then I'm just going to copy down the rest of this. So minus 10. Let's change the order just for fun. Since that leads with a negative, we could go ahead and say that's the natural log of 1 plus 10 over x minus 10 over x plus 10. I think that's a good place to leave the answer. So let me know if MyMathLab doesn't accept that, and if it doesn't, then I'll go ahead and take a shot at simplifying it. I hope this was helpful. If not, please let me know.